Hello all, welcome to Abhiram Ias Academy. Let us go through the daily chronicles of January 17th, 2025. So we are going to discuss about the ISRO that docked 2 satellites, what is the significance of this, and also Cabinet has approved the new third launch pad. It is relevant for your GS3 space topic and subtopic ISRO's role in national development. ISRO has successfully docked 2 satellites in space in zero gravity environment. The 2 satellites are Chaser and Target, and they were 20 km apart before this docking. Okay, they were at a height of 470 kilometers altitude above the Earth, and each of them has weighed 220 kilograms. So they were conducted under SpaceX, that is space docking experiments, launched under PSLV C-60 launch vehicle. It has put India on the elite league of countries which has successfully conducted such docking mechanism, that is US, Russia and China, and we are the 4th country to achieve this. We are yet to conduct the post-docking test for this. What is post-docking test? These are a set of tests intended to check whether the satellites are operational as intended. This test is mechanical fit, alignment and orientation. So mechanical fit is to check whether the satellites have docked perfectly and are their latches perfectly without any gap. Then we have alignment and orientation test. So the satellite need to be placed in specific location. It has to observe some celestial objects, or it has to conduct some Earth observation from a specific location, or it needs to be placed in specific location to reach the ground stations for communication. So all this needs this test, that is mechanical fit, alignment and orientation test. We also need to check if the satellites are communicating effectively. For example, we may need to check the electricity transfer mechanisms and also the data transfer mechanisms. The 2 satellites may be operating individually before docking, and once they dock, they need to communicate about their data, about their analysis. So that is possible with data transfer. In space, in zero gravity environments, the satellites may be subjected to some physical or mechanical stresses, like high speed, vibrations may be caused, and also any kind of impact may happen. So to withstand them, the satellites need to be checked for structural integrity. That is also a post-docking test. Then we have separation and undocking. Once they are docked together and they communicate, they need to separate for individual operations of their own. So we need to undock them and separate them also. So that is also post-docking test. So all these tests are planning to be conducted in the next 2 years. This docking experiment will open a gateway to all the new possible opportunities like this. That is, it will offer technological support in zero gravity environment for multiple purposes like satellite repairing or servicing, in-orbit refueling, and also modular spacecraft construction. So let us go through this. Satellites, when they are in space, may run out of fuel, so they need refueling. So this is possible if a new satellite comes and refuels the satellite. So that is possible only with the docking mechanism. And we also have satellite servicing. Just like vehicles, satellites also need repairs, maintenance. So all their servicing requirements may be carried out if we have a new module attached to it. And in future, some astronaut may come and repair the satellite. Okay. And then we have modular spacecraft construction. So instead of a heavy launch vehicle carrying a heavy payload in a single satellite, we can have modules, different small modules, which can be taken up and then combined to form a larger modular construction. Okay. So this is how we are planning to achieve the Bharatiya Antariksh Station, where we have first module to be launched in 2028, and it is going to be fully operational by 2035. This docking experiment will help us unlock the long duration space flights which need lot of endurance. That is, they need to stay in space for extended periods. That is possible only with lot of resupply, okay, or refueling. So all this will be possible with this docking. And then we have the reduced reliance on the heavy lift launch vehicles. That is, instead of heavy lift launch vehicles which are costly and they don't have any flexibility to incorporate any further additions in future. So instead we can go for smaller modules which can be collaborated in space after successive launches. The docking experiment is also crucial for our future missions like Bharatiya Antariksh Station, which is to have our own space station by 2035. Then we have Gaganyaan like crewed missions. okay, where we are sending astronauts into the space at an altitude of 400 to 450 kilometers, that is in low Earth orbit, where the astronauts orbit in this and they will conduct some experiments and come back after few days. And then we have Chandrayaan 4, where we are planning to collect some moon soil or regolith, get it back to Earth. So this also needs docking mechanism. Cabinet also approved a third launch pad at Sriharikota apart from the first and second ones. The first one is known for its PSLV launches, and the second one, there are some significant launches like GSLV, MK3, and the next generation launch vehicles like Unified Launch Vehicle, which will carry different modules into space, and SSLV, that is small satellite launch vehicles. These are to be planned in this third launch pad. It will also act as a standby launch pad to the first and second ones when they are under repair or maintenance. It is worth 3,984 crore. The next article is about Indian Meteorological Department's journey and its contribution to the national development. It has completed 150 years. Okay, it was established in 1875. So we are going to see IMD in detail, and it is relevant for your GS3 paper, application of science and technology in various fields, and also role of IMD in disaster management, which is in GS1. So IMD, Indian Meteorological Department, was set up in 1875, and it is our national weather forecasting and monitoring agency. It has multiple functions like conducting climate research and any kind of weather updates and predictions, both short and long term, and also early warning for adverse weather events. What are short-term and long-term weather predictions? For example, we can have humidity, temperature or rainfall in a day that will come under short-term, and long-term means any kind of weather forecast for the monsoon, okay, monsoon patterns or seasonal forecasts. All this can come under long-term weather predictions. We also have early warnings for different adverse weather events like cyclones, heat waves, all these. Let us look at agriculture. Accurate prediction of the monsoon patterns and its timing can be helpful for farmers in their sowing decisions, okay? And if there is any drought also, we can communicate it to the farmers in advance. So how does it help in road and rail transport also? So any kind of intense adverse weather phenomenon may be predicted and communicated in advance to the locals. And also fog, which will affect the visibility in rail transport. So that is also important. Then we have flight operations. So wind patterns and turbulence forecast, and also fog or any kind of thunderstorms may be predicted by IMD. So it is important for aviation also. And then we have power plants, especially the renewable ones like solar and wind, which heavily rely on IMD's weather forecast. So if we want to select a site, we need to know how much amount of solar insolation is available in that specific location. So that will help in deciding the location of the plant. And also wind patterns, wind speed, wind direction, all these are needed in wind power plants also. That will help in managing the energy production. And tourism also. So if you want to go to some beach location and there is a heat wave, you can be warned in advance by IMD weather forecast. And also if you are in Shimla and you need to know about the snowfall also, IMD will help you. So that is how it will help in tourism sector also. So how does IMD help in power plants management? So it will help in predicting the wind speed and direction also. Using the Doppler radar systems, we can assess the wind patterns and also their speed and direction. And there is another thing called as GHI forecast, that is Global Horizontal Irradiance Forecast, which is nothing but it calculates the amount of solar insolation received in a particular horizontal surface, which will help in determining how much solar insolation is received, okay? With that, we can know how much solar energy can be produced. And also, if we look at the historical day-wise maximum and minimum temperatures, we can come to a conclusion that the site is suitable for solar or wind power plants. IMD also helps in disaster preparedness and management by giving accurate prediction of different disasters like droughts, cyclones, and intense rainfall events, and also heat waves in summers. Early 2000s, the accuracy of IMD was just 20%, but after 1999, Odisha super cyclone, IMD has significantly upgraded its technology and improved its capacities. We can see in 2020, the accuracy has come to 80%, and it also is giving probabilistic forecast for extreme weather events. There are different kind of forecast like nowcast. Okay, this is for a particular day, and then we have seasonal forecast also. This will give an idea about the upcoming season. For example, a winter may be severe or mild. We can know by seasonal forecast. And then we have probabilistic forecast. So probabilistic is where the IMD gives a range of outcomes, not one specific outcomes. That means there will be rainfall, whether it is mild, whether it is severe, how much will be the So that is probabilistic. And then we have deterministic. So deterministic is where the IMD is sure of a specific outcome. That is, it is highly accurate about the specific outcome. IMD uses state-of-art technologies for its weather updates and forecast. So like automatic weather stations. These are automatic without human intervention for eliminating any kind of errors. And then we have automatic rain gauge instrumentation also, like tipping buckets and also weighing sensors. So these sensors will help in calculating the amount of rainfall. And then we have Doppler radars. They are a specific type of radar that works on Doppler effect. They will send out radio waves to some moving objects like raindrops, okay, and then help in assessing their direction and speed. Then there are also observatories. It is a network of both surface and upper atmosphere observatories which will help IMD in predicting the climate patterns and weather forecast. Mission Mausam is about upgrading IMD's infrastructure and capabilities by establishing a network of Doppler weather radar systems across India. It will try to establish 15 radiometers and also 15 wind profilers, which will help in surface and also upper atmosphere observations. Then we have cloud chambers also. In this, cloud chambers are nothing but the devices which help in assessing the process of cloud formation by analyzing the interaction with the aerosols. Radiometers are nothing but the devices which use technologies like remote sensing to help in assessing the temperature, okay, by observing different radiations in frequencies like microwaves and also radio waves, infrared or visible light. So the radiation from different frequencies can be observed to obtain the temperature profiling of the surface. So that is how radiometers will help. And also wind profilers. Wind profilers are nothing but the devices that measure the vertical profile of the wind and help in assessing the wind patterns or movements, their direction and speed also. So these are important for surface and upper atmosphere observations. The project cost 2000 crore to be spent over 2 years. So that is about Mission Mausam. IMD has released a vision document for 2047 in which it outlines numerous goals of IMD like mainstreaming the weather and climate information. Right now it is only limited to specific high technological institutions, but it wants to mainstream it by decentralizing and spreading its Doppler radar network across India. And also another target is zero loss of life. This is the ultimate target. We cannot afford to lose any life. And then it wants to have zero error in 3-day forecast, whereas for 5 days it wants to have 90% accuracy, and 7 days it wants to have 80% accuracy, and over 10 days it wants to have 70% accuracy, and 100% detection for all types of severe weather events. And not just at a broader level, but at household and village level prediction has to be made possible. So these are the goals outlined in the IMD vision document. IMD also faces some challenges, like it is unable to have deterministic forecast, especially for the long-term monsoon patterns. So monsoon patterns are altering, especially in the event of climate change. So there are changes in the monsoon patterns, and IMD is unable to give any specific deterministic forecast for this. And in some cases, there are localized flooding events localized extreme weather events. For example, in 2024, Delhi rains, and also in Chennai, heavy flooding has occurred. So IMD was unable to predict them. In Chennai case, it predicted the rainfall would be moderate, but it ended out to be heavy rainfall, even flooding has occurred. It is also difficult to predict the weather patterns, especially in the event of climate change, because climate change has some feedback loops. Okay, the feedback loops between the ocean currents and also atmospheric weather circulation, all these parameters will determine the weather. So these changes are difficult to predict. So that is one challenge. Urbanization is also creating new challenges. For example, population density is high, so any kind of small event also will lead to heavy loss of life if it is extreme weather event. And then we have heat island effect. The concrete structures will trap the heat, and the temperature in this city will be higher than the surroundings because of the reduced vegetation also. So that will lead to localized weather phenomenons, which is difficult to predict. So that's it for today. Thanks for watching. Please subscribe to Abhiram Ias Academy.